Well, this guy's a little different in that what I notice is each one of these terms are fractions. And the way we handle that is that what we're going to do is that we're going to essentially clear the denominator. And we're going to clear the denominator by looking for a number that 5 and 2 and 3 all divide into. 5 and 2 and 3 have nothing in common. So if I would just multiply them like you would do in arithmetic, this would be 30. Does 5 divide 30 evenly? Yeah. Does 2 divide 30 evenly? Yeah. Does 3 divide 30 evenly? Yeah. Use 30. Now, as I told my college algebras last hour, when I look at a problem like this is what I see. I have a left-hand side and I have a right-hand side. Those two sides are equal. So that says whatever I do to the left, I must also do to the right. I could add the same thing to both sides. I could subtract the same thing from both sides. I could multiply both sides by the same thing, as long as I'm dealing with two sides. I have a clump equaling a clump, and I don't care what's on the inside. Those two inside things are equal as a grouping. That means if I were to say I'm going to multiply the left-hand side by 30 over 1 and the right-hand side by 30 over 1, because I'm doing the left and the right by the same number, I'm going to end, they are still equal. And I chose 30 because it's going to kill the denominator. So if I look at this is going to be 30 over 1, and this is going to be multiplied times 3x over 5, use the distributive property, minus 30 over 1, which is going to be multiplied by x minus 3 over 2, equals 30 over 1, which gets multiplied by x minus 2 over 3. Now what you notice is that 5 divides 30 6 times, so this first term just becomes 6 times 3x, with the 5 being gone. There's actually a 1 down here, so the denominator is 1. And the 1 denominator means the denominator is gone. 2 divides 30 15 times, so this becomes subtract 15 times x minus 3, because 2 divides 2 once, divides 30 15 times, that denominator becomes a 1. And then 3 divides 30 10 times, and 3 divides 3 once, denominator is again gone. This is 10 times x minus 2.
Shouldn't that be a plus 2?
Probably. Thank you. That would have been an adventure, huh? I would have gotten the answer, but would it be to the original problem? No. It would be the correct answer to the problem I worked, but not to the problem that was given. And that happens. So now, clean it up. This becomes 18x. Minus 15 times plus x is minus 15x. Minus 15 times minus 3 is plus 45. Equals 10 times x is 10x. 10 times plus 2 is plus 20. Combine like terms, 18x plus 15x. Now remember, these are two groupings. I'm not moving things, I'm not changing signs, I'm just taking the left-hand side, which is an expression, combining like terms, cleaning it up. There's the equal sign, taking the right-hand side, which is an expression, cleaning that one up, and then I'll have it in a position where then I could solve the equation. So this becomes a 3x plus 45 equals 10x plus 20. Now if I stop and think, if I put the x's on the left, I'm going to subtract 10. 10 is, negative 10 is going to make this a negative on the left, right? So that says, what if I put my x's on the right? Instead, I'm going to subtract 3. That's going to give me a positive number. So you can either work that direction. So I'm going to choose to put my x's on the right and my numbers on the left. That means I'm going to subtract 3x from both sides to move the x's over. And since I want my x's on the left and my numbers on, my x's on the right, my numbers on the left, I'm going to subtract 20 from both sides. And now that's a multiplied x, so I'm going to divide so that x equals 25, 7. So that's your solution. And all its gory detail.
You get the same answer regardless which side you put X.
Yeah, because if I would have brought it to the other side, I would have had this instead. Right. So then I'm going to divide both sides by negative 7. Negative divided by negative is a positive. It's just I'd have negatives running all over the place, which is not always a positive thing. Yes?
So could you try and simplify it a little further at the 3x plus 45 equals 10x plus 20 point and take out like a like term? So for 3x, do like a 3 parentheses x plus 15?
No, because that would complicate matters because you'd have to multiply it back through. Because what you want to in the end be able to do is to combine like terms to simplify.
So don't
So once you've
simplify
got, don't simplify that.
until you've crossed that.
Correct. Yeah. Because factoring that thing is just going to drive you crazy. Might drive you crazy anyway, but. We're now going to head into the world of inequalities. And it says graph the solution of each inequality on a number line. And that says suppose I have x greater than negative 4. I just draw my number line. And put in, this does not include negative 4. And I usually use an open dot. Your book will use parentheses. You can do that once you put it in. I want everything bigger than negative 4. So when x is on the left, the arrow points the way. What your book would have instead of this open dot, it would have a parenthesis. So the answer would look like this instead. I have problems with the parentheses and the square brackets because how do you know which direction it goes until you have your number line shaded? How to cap it off. And I find in college algebra, I use circles and solid dots. So open circles are parentheses, and then solid dots are going to be the square brackets. Include versus exclude. Now, if I'm going to use parentheses and square brackets, the first thing I do is I want x's that are smaller than or equal to negative 6. So I'm going to put a little line here and put negative 6, and I want everything smaller than or equal to it. That says that the stopping point is everything's to the left. That means I need a square bracket here at negative 6. Then I can put the bracket in. Include, square bracket, exclude, parenthesis.
Do you have a preference for like tests? Can either one be correct? Or
Oh, sure.
Okay.
What do you mean preference? Circles or brackets? Or
Yeah.
Yeah, That,
What
yeah,
about a circle and a closed circle?
yeah,
That's what I.
because that's what I use. Your book uses the square brackets and parentheses, but I use open and closed circles because when you get into college algebra, you have so many of these things on the number line that if you try to use the brackets, it's going to drive you crazy. So maybe you'll have 3 positions on the number line. Trying to put parentheses in is going to drive you crazy. Or trying to put square brackets in is going to drive you crazy. You can drop it down afterwards, which is what you'll see on the next thing when we talk about interval notation, but it'll just drive you nuts. So the open and closed dots, I personally like that better. This is between. This says x is going to be bigger, or is actually the word here I would think for myself is the word between. I'm looking for numbers between -2 and 7. I include -2, I don't include 7. So I drop my number line. If I include -2, that's a solid dot. And if I exclude 7, that's open. And then it would be everything in between. Now your book, if I were going to approach it the way your book does, I'd put a little thing at -2, little thing at 7, shade it, and then it says, oh, it includes, so that would be square bracket. It doesn't include, that would be parenthesis, so I could get that in correctly. The reason why they use that notation is to going into something called interval notation. How many of you have already seen interval notation? How about half of you? Yeah. And it's just it is a drop from the number line. Yeah. Thank you. Okay, I know she's not here. Got an email from her. Elijah?
Yes.
You have a paper? Oh, yeah, he emailed me. There you go. Courtney Phillips. And Jujie. Oh, back row got missed. Okay, thank you. Okay. Now, we primarily, oops.